Thank you, Eric. And actually, the work that I'm going to be presenting was in some way motivated by the sensitivity approach that Oriana mentioned, but it's actually what the sensitivity approach gets at is average changes, and this new approach is looking at a way to maybe get at extreme events. So it's a little different, but the concepts are a lot the same. And this is really preliminary results. This is really the first time I've presented it, and there's part of me that wants to hold on to it and get to know the data better, get to play with more things, tweak more things. But I think this is a really important opportunity to be able to share it with you while I'm in the process of kind of figuring it all out, and really to get your feedback. And especially if you're in the water management community and practitioners, please write down notes, give me feedback, contact me, meet up for coffee. Like I really value your feedback to see if this is a good direction to go forward or if it doesn't make any sense. And so Oriana talked a lot about the way that we go about looking at impacts assessment, starting with the global climate models, downscaling it, running it through a hydrologic model, routing the flows, bias correcting it, then running it through a management model, and then at the very end getting at kind of what the impacts are. And I think this has been a really effective way at getting to understand impacts. And I've gotten to be a part of various efforts. And people say it's helpful, but you also hear things like, how do I deal with all this data? Is this approach appropriate for the impact that I'm interested in? Because you're going from a global scale down to a much more local scale. The assumptions that you make to span space and time are more appropriate for some impacts than for others. And then the question of how does this information fit into my day-to-day management? And so what I've been interested in exploring is, are there other approaches to understanding climate change impacts that, instead of starting with the global climate models, start with the impact? So kind of taking the traditional approach and kind of flipping it upside down. And you can't run models backwards. So starting at the bottom and going up, you have to think about ways that you might work your way up the model chain through identifying thresholds. And let me explain the way I've thought about how we might go about doing this. And again, thinking about how to look at extreme events has been kind of the driver of this particular approach. So first, identifying what your extreme event is. And this is working closely with whoever it is that you're going to be providing the data to, and kind of identifying what is that extreme event that you're interested in exploring. Then using the same models, but now you're going to iterate using the hydrologic model to find out what leads to an extreme event. So is it 1 day worth of weather, or is it 3 days, or is it a whole season? Like, what is it that defines that extreme event? And then ultimately identifying patterns and doing some sort of pattern matching with the global climate models and seeing how often you're seeing those sorts of events in the future. And so in order to do this, the first thing was to identify where can I experiment with this new approach. And so the three criteria that I was looking for in where I might do this was, first, the need. I wanted to find a group of interested stakeholders so that I could interact with them and get their feedback. I wanted a place where the performance of the model that I was using it performed well, and ideally that I could build on an existing project. And then finally, I also wanted a place that had interesting hydrology, so that a place where the soil moisture and snowpack mattered. And so the place I ended up selecting to kind of explore this was the Skagit River, and they deal with floods a lot. There's a group of scientists and people engaging the community, the Skagit Climate Science Consortium, and Alan Hamlet and the Climate Impacts Group have done a lot of work in the basin, and they have a model that they have let me use, and so this was where I've started, and I'll kind of go through some of my very preliminary results, which will explain a little bit more about how I'm doing this. I used the variable infiltration capacity model, one of the models that Oriana talked about. And here I'm just looking at a single grid cell, so one 5 kilometer by 5 kilometer grid that's located in the Sauk River at mid-elevation. What is plotted here are, I've identified 30 initial states using the historical record on December 28th, and I'm using a single day of meteorological forcing, so temperature and precipitation, from the day the event happened, so December 29th, 1917. And the red line here is the event magnitude, and so that's what I'm defining in this exercise as my flood. And what you can see is if you have just one day of meteorological forcing, you only have one initial state that gets it, and that initial state is actually from 1917. So it's identifying the day that you actually do get the flood. Now, if I have one day of the event, what if I have two? So stepping back in time, and you can see that the distribution shifts a little bit closer to that magnitude, or that the event, the magnitude of the event. And then I can step back in time further. So 3 days of weather, 4 days of weather, 28 days of weather, and you can keep going back in time and use this to identify, like, where are your thresholds. And I just want to highlight 4 days, you get all of your values to be greater than 100 millimeters in this particular grid. And then, say, around 17 days, you're getting things to converge, so your initial conditions or your initial state no longer matters. So if you have just 17 days of weather, you're going to get that event, regardless of how much snowpack you had, regardless of what your soil moisture is, you're going to get that event. And so here is another way of looking at it. Hopefully you can see some of the spaghetti diagrams. It's lighter gray than I would like, but it's providing a lot of exactly the same information that was on the previous graph, except each of these traces is one of the initial conditions that it comes from the historic record, and then the red line is the event. And so here again you can see where the 14 days are, and then again when those days converge at around 17 days. And so now you can look at another event, and here is just an event that happened in November of 1999. This has a different signature, and for those who can't see the gray, it's now ranging from here to here. So it hasn't yet converged, so I have to step back further in time to get at it, and so here it finally converges about halfway through the year. So for this particular event, the initial conditions matter much further in the past than the other one. This was all of what I've showed you so far is for a single grid. I wanted to check to see if I can scale this up to a river basin level. And here's just a figure comparing, looking at the same event with a single grid and looking at one that's for the Sauk River, and the patterns are the same. You get a little more smoothing when you scale up, but it's possible. So that was kind of a good reason to keep moving forward. And now the question is, so what can I do with this information? So this has maybe been an interesting exercise, but what does this information mean, and what implications can it have for management and kind of thinking about climate impacts? And so here is one of the events that I've mentioned. Here there's more lines on the figure, so more initial conditions. I've used the entire record, historical record of initial conditions. And what I would now ask is, how many days of weather are needed to get X% of initial conditions to be greater than X amount of runoff? And these X's are really something that I would go to the management community and say, can you fill in these X's? Like, is it 50% of initial conditions that you want greater than 150 millimeters? And ultimately, this would be river at a gauge or some other measure. And so here I've drawn that black line is looking at the magnitude of the event, so 150 millimeters. And then I can look, so with 1 day of weather, 28% of the time I was going over that threshold. 2 days of weather, 39% of the time I was going over the threshold. And then 3 days, over 50% is over the threshold. So for this particular event, I would, with these thresholds, you would say, okay, it was 3 days in order to breach those thresholds. And so that might be the event. And so now then you can take that information and look at other events and see kind of, are these characteristics the same? Can you identify what creates an event or not? And then also, I think, looking across these different days, you can also pull out some interesting what ifs. And so these are the top largest events for this particular grid. And you can see that in 1990, which is the largest event, it's at the top of the ensemble of initial conditions. So it's kind of maxed out its initial conditions. Whereas in 2006, it's in the middle of the initial conditions. So if you had had wetter conditions in that system, you would have actually possibly gotten a bigger flood if you would have had initial conditions that were wetter. And so I think this is another way this information can be used. Another thing about this particular approach is getting at kind of the language that I've heard management talk about extreme events and talking about it in terms of specific years and references to the past. So an example might be if conditions were similar to fill in whatever year, the particular event would have been of this magnitude. Also, with the way this is set up, you could ultimately provide there's a percent change, a certain likelihood that you'll see a flood that's similar to what we've seen in, say, 1999 in the future. And so I think it gives a language that is references the past, which is often helpful because people do like the analogs. So in summary, this is a new approach, and so I'm kind of sharing it with you in hopes to really hear what you think about it and to get some feedback. I like it because I think it encourages a decision maker engagement at the very beginning and throughout. So as a first step, the first thing you have to do is go out and make the connection with whoever you're providing the information to. I think it's helpful that it looks at system vulnerabilities before even looking at climate change. It also kind of quantifies what's familiar. So I would imagine some of these results are going to be something the management community would know already. There might not be any big ahas in terms of what you're seeing just in the historical record, but it would help to quantify exactly what you're looking for when you're looking for events in the future. And also, I think it would be very complementary to the more traditional approach where you could begin to identify ways in which the events are changing in character as well. So the two approaches can really complement each other as well. And really what I've presented thus far is really focused on the hydrology. And so for next steps, it's going and first we're taking a pause, getting feedback and seeing, is it something that we should move forward with this and really getting that feedback. But then moving to quantifying exactly what those weather patterns are and then looking and identifying those in the climate system. And so with that, I want to acknowledge the people who have helped me along the way and also ask for feedback and questions. And really, is this information useful or not? If it's not, please let me know that as well. So, thank you.
So I guess this is not a question. This
Yeah,
is
yeah,
feedback.
I'm asking.
Feedback moment.
Okay.
Go ahead, Jim.
Feedback. I'd be interested to hear what kind of feedback you got from the folks in the Skagit on this approach, number one. And number two, from an energy and from a fisheries perspective, we would be more interested in the low water events, the critical period, if you will, for both power production and fish.
Yeah,
like
yeah.
2001, or the critical period for power studies.
Yeah, yeah.
Would this approach be conducive to look at that?
So I can get back to you. I'm still this is the first time I've really presented it, so I haven't had a chance to get feedback, so I don't have that to share yet. But I think one of the things about this approach is, and here are some figures that I just put together looking at low flows. And so you could do the same sort of experiment with low flows, or you could look at highest flows in a particular month. So not necessarily the biggest flows, but say you're really concerned with flows in June. And so you could explore that. But that goes back to kind of why it's so important to interact. I mean, this is not going to be a one-size-fits-all where you'll be able to provide the data on a website that can be downloaded and used. It really requires kind of that conversation. So, yeah.
Which I have a follow-up to Jim's question, because actually what Jim is asking, if I may, that's a joint probability question. It's not just low flows, it's low flows and you can't generate, or low flows and temperatures reach a critical level. Can you expand this into joint probability questions?
You
Maybe.
need to couple it with a temperature model.
Yeah, I mean, you would have to include other models in that to answer it. And it might become a little unwieldy, but again, maybe.
Other questions? I have one.
Okay.
So, I mean, to me, this is an interesting way to look at extreme events without getting into the whole argument of 100-year flood, 500-year flood, is 100-year flood going to increase in the future and all that. But anytime I see a new method like this, I always also bring up the question, and I'm going to bring it up to you, is what would you not want to see this used for as the person proposing it? In other words, if you saw someone taking this approach and did X with it, you'd be horrified.
Yeah, no, that's a good question. And I mean, I think because it's not an off-the-shelf, you would have to have that conversation for where it would be appropriate and not appropriate before you even develop the method, or develop the particular model for the basin. You might get away from some of the, oh no, don't use it for this. But I haven't really thought of specific examples where you would certainly not want to use this for. And really, I mean, first step, developing it for floods, and then maybe developing it for low flows, and then kind of going from there. But
so what I'm hearing there is it would really be a question of talking one-on-one with stakeholders.
Oh, yeah, yeah. Method. I mean, I don't think you can apply this method unless you have a specific impact in mind. By definition, you're defining the thresholds around that impact, and so you have to define it at the beginning.
Okay, interesting. Any other questions? Thank you very much.
Thank
Great
you.
talk.